Hey everyone, welcome to Your Desk University. Looks like my audio is a little loud. I'm going to bump that down a little bit, but we're really glad to have you. I see quite a few people in the stream. Now, this is a really special workshop series. I want to say thank you to Ehsan and to Dana for offering this. Hopefully, I looked the right way. I didn't. Thank you to Ehsan and to Dana for putting this together. They kind of came to Your Desk University and said, "Hey, we want to put together this workshop. Dana wants to learn a little bit about Python." Ehsan was offering to teach it. If you don't know, Ehsan is the father of PyRevit. He works at Rhino McNeil. But he is doing this here as a gift to the community. He is huge and massively generous to our community, and really one of the reasons I started Your Desk University with the collection of people, because of people like him who are giving so much to the community. We wanted to give back, and this is our way of doing that as well. Definitely, if you don't know Dana, Dana is a BIM technologist at Smith Group, and she's in the DC area with myself as well. We've known each other for quite a while. My name's Tim and Hazel. I'm a senior technical designer at Walter P. Moore, and I am definitely grateful to all the people that I see here, and these two, and all the people who've been a part of the Your Desk series. I also do want to say we haven't quite announced it, but in 2 weeks, we're going to have our first Your Desk University 2021 typical series session. So these workshops, these are a little bit different. This is the first time we're trying this thing. If you like it, definitely hit the thumbs up. Those are huge. If you don't know this about YouTube, but those thumbs up help people know to see these. This workshop is a little private, so it's public right now, but we're going to unlist it. And everyone who's here signed up for it. So wow, guys, this has been, I mean, there's been so many people that have wanted to do this. And let's see, there was a couple of things. Oh, yeah. So we're going to start with Havard Vasaug next Thursday, and then we have a full series of people. So make sure you keep an eye out for that and reserve your Thursday, Wednesday, and Thursday for the in 2 weeks, the 24th and 25th, and then after that it'll be every Wednesday from 4 to 5. With that, we definitely want feedback. We want you to be involved. We have a Slack channel set up. Definitely get involved in there. There's a specific Python channel because there's so many people taking this course. Want to try to keep that conversation in one place so other people can see it. Some really good conversation in there about how to install Python and things that people have already been seeing. So with that, Asan, Dana, I'll turn it over to you, and I might pop in and out here, but other than that, it's all yours.
Thank you
Okay.
so much, Timon.
Oh, I
Thank you,
guess
Tim.
one more thing, and you guys know this, but I want to tell them, is that we're going to try to record this and then parse it in chunks. So if there's an awkward pause or refresh and start, that's because we're really going to try to kind of parse this out. We don't know if that'll ever work, but we want to try to record in that way, so don't be
Yeah.
surprised if that happens. So with that, I'll let you do an intro.
Do not do
Thank you.
not touch your receivers. Is the problem is from our side.
Yeah,
Oh,
definitely.
okay. Let's do. Are you ready, Dana?
I'm ready. I'm excited. I hope
Okay.
everybody is excited as I am.
Do you want to do like a 10-minute recap on the previous session?
I definitely think we should. If nothing else, just maybe like a breeze over to refresh us a little bit. I have the Notion page open. I don't know whether everybody else does. I see you're displaying it. Maybe we can get that
Sure.
shared up for everybody, Timon.
And we're going.
One also little caveat that I want to throw in here, being that once again, as Timon mentioned, this is a very new thing that Your Desk is doing, and that it's very new for Ehsan and I as also obviously. Is we really did this live to foster the questions from the chat, which is why we asked everybody to be beginning or beginner Python users. So please, especially in this workshop after the first, where it's after the introduction, if you will, we encourage you guys to ask questions as we go through this. I may ask them as they are my own. Once again, as Tim had mentioned, we're going to try to parse this into chapters, but we really thought that doing this live would not only benefit you guys within the community, but also with just once again fostering as many questions as we can have. I can't think of everything, right? As you guys can see, I am very new to Python, so learn with me, of course, but please also ask your questions in there. So thank you so much, and I will be looking at the chat and trying to monitor that. So thank you, and
Okay.
thank you so much, Ehsan.
Of course.
Without further
So
ado.
I just posted if everybody can start their questions like with a snake emoji or something like that in the chat. It makes it a lot easier for us to sort of like see them and notice their questions and everything. Okay, so I have the page for the previous episode open. If you don't know what this cover photo is on top of the page, that's a PDP-11 machine. That's the machine that Unix operating system was designed on. We'll talk about that at the end of this session today. In the previous session, we talked about what is a program, basically, touched on algorithms and flowcharts, and we played with Python a little bit. We talked about interpreter, how the Python interpreter works, and as we type stuff, it interprets everything, right? And then we kind of used Python as a nice calculator, easy calculator to work with. We talked about the print statement. One of the most important parts of our discussion was about the data types, like integers, strings, floating point variables, and then the sort of like dealing with lists and set and dictionaries in Python. And then at the end of it, we wrote a little piece of program that was supposed to print the Fibonacci numbers for us on the screen. But we noticed that sort of like between the two different variations of the program, there was a difference on the output. And we didn't talk about it in the previous session. We'll talk about that right now today. So with that, let's move on to the contents of the episode 2. That's going to be our discussion for today. I have a flowchart open here that we'll talk in a little bit more detail later on with you. But what I want to talk about first is bugs. Bug is an error in a program that you have written that sort of like causes the program to fail or behave in a way that it wasn't supposed to behave. A lot of times the things that makes the program fail, or if it's a syntax error or the way that you have written the program, the tool chain that we use to write the programs like Visual Studio and Python itself and all the other sort of like little tools around it that we use to develop our program, they usually capture a lot of these errors for us. Like, for example, if you don't have the semicolon at the end of a Python block, and we'll talk about blocks more, the Python sort of like interpreter will capture that for you and tells you that, hey, you made a syntax error here. The biggest problem with the bugs, or the biggest sort of like most common types of bugs that you see out there, is the one that we saw in the previous session, and it's a logical bug. We write something that is a valid program, but it's not doing what we intended it to do, right? So it either crashes itself at some point or the other program that it's going to write on. This category of bugs are the ones that usually you see that, let's say, corrupts a file. Why? Because it's capable of writing and reading that file, but the content that it's writing is not valid because there's a bug somewhere in the program. And these are the hardest to capture. In the previous session, I'm going to zoom into this a little bit. In the previous session, if you remember, we wrote this the first time. I'm going to make this one zoom also. The first time we wrote this, we didn't use this sort of like condensed version of the assignments, and we wrote it like this. And I'm going to turn this into a comment. We wrote it like this. The difference between that and this is that when a computer is executing every single line, it comes here and it says, okay, A, put the value of B in A, and then add B and A together and put it in B. So it's going to use the updated value of A and put it in B, pretty much adding B to B and putting it in B again, right? This is a logical bug. That's not what we intended it to do. We wanted to swap the values for this and add the A to it. So in this format, when we're writing it using the connects method, when the computer gets to this instruction, it goes in and says, okay, the B, I don't need to do any mathematics on it. So B is value of B. B plus A, so it uses the previous value of A, which was here, and then adds it to B, places it in B, and the previous one is placing the B inside an A, right? So the difference between these two programs was that one of them is updating the value of A and then adding it to B. The other one is not updating the value of A. So that's why we saw a sort of like a bug in a program that one version it was working correctly and the other one it wasn't. So if I change that really quickly here, just so we have, let's get rid of that one and use this one that's bigger, Python 3. Can't type today. Save that one, copy the path, place it here. If you're on a Unix system, Unix-based system with forward slashes for the separators, space needs a back in a normal slash right after it. That's how you define a space in your path. I don't know why Visual Studio Code doesn't actually add that, but this is the incorrect version of our program. If you switch it with the correct version, okay, switch to, okay. So in this version, now we are seeing that it's actually working correctly. There's a question that says, is there a mouse cursor if talk about the code can be not just not, okay, yeah, we're good. Okay. Yeah, my mouse is probably a little bit small. I'll try to select these things so you can see them easier. So does it make sense, Dana, the thing that we were talking about, the bugs?
Yes.
And the problem
and how different programs are interpreting the math differently.
Yeah. And did you follow? Was it clear why our program wasn't working correctly?
It's a little bit of a unique example, but yes, I get it more or less.
Okay. Do you want to talk
because
more?
the A and B value are stored on the original line on line 1, right? You're basically telling A and B what their values are. But then later it gets confused, right? Because you're in the equation, it's trying to define what B is, but you've already defined what B is.
Okay, so let's talk about it. Let's talk about it the other way. Let's discuss it in terms of orders of operation, right? Remember the tape and the fact that the computer is running line by line, right? When it gets to this line, this is the correct version of our program. When it gets to this line, the first piece that it starts evaluating is this thing here. Why? Because this is an assignment, and what's on the right hand of the assignment needs to be evaluated first, right?
Because I think also, Tim, and I'm getting a really weird lag on the OBS screen share. So like when he's selecting things, it's not exactly clear what he's doing.
Switch to Teams?
Yeah, let's switch to Teams. I'll still be on the OBS so that if we want to do the dual share, right? Okay. Sorry about that, guys.
No, you're fine.
Yeah, it looks like I'm not the only one with the seeing the lag. Okay, and that's maybe why it's leading to a little bit of the confusion.
My Ninja.
Okay, that's better. Okay, there we go. Yeah,
leave it open. Okay.
I'm gonna.
Okay, so here, can you see my screen now?
Yes, and I see no lag. I see, and I think that's what Thomas was talking about earlier with the mouse cursor, is we were seeing a lag.
Okay. So the order of operation, when Python gets to this line, it looks at this assignment and says, I need to evaluate what's on the right hand of this first. Why? Because these are the values that are supposed to go inside A and B. Does that make sense?
Yes.
So it's going to evaluate this, take the value, and then it's going to evaluate this and calculate the value. But it's going to use the value of B and use the value of A that's coming from the previous line, whatever that was inside an A, inside the A, right?
Right.
If you write this using this, so our intention is that A will hold the value of B, and then B will hold the value of previous B plus A, right?
Right.
So this is what we want to do.
Mm-hmm.
They look the same, but in this version of the program, B is getting assigned to A first. In this version, we wouldn't do that. We use the value of A from the previous lines, and we'll sort of like evaluate the instructions. Did that make any sense?
Yes.
Okay. Okay, so that's what I wanted to talk about bugs, basically. One of the other things that sort of like I wanted to touch on, because we're going to talk about this in today's session a little bit more, is, let's see if I can find my Safari. Yeah, okay. So the algorithm that the flowchart that we talked about in the previous session, our program usually starts from a single place. It goes through a series of actions, series of decisions. It branches out in whatever direction that it needs to go. In most cases, a program doesn't have one ending. It has many different endings. Sometimes you sort of like depending on the program, the options that you provide to a program might do sort of like different things. Depending on those options and inputs. So a program a lot of times can have multiple different endings. The trouble is with this is that we talk about program as a form of a sort of like a tape, right? So we kind of expect everything to be on a single tape. What we do when we're actually programming, we're doing this. We're taking these and literally like putting them right after each other. Let's see, this was here. So the decision goes here, and then it goes back to this, and then we take it here, right? So as you can see, like let's just start a program, we'll do something, make a decision to something else, and the program ends here. But we still have other stuff on the tape, right? This is the decision that we tell the machine, we tell the operating system that, hey, we're done with whatever we wanted to do. This is where we end, right? But we have still stuff on the tape that, depending on other decisions as in other part of the program, we might jump to them, right? So we have this capability inside of sort of like running a program to jump into different pieces of the program. That's one of the reasons that every programming language kind of needs a concept of a block, right? So we have this block. This is a loop block that sort of like loops until this condition is, as long as this condition is met. And this is a block that's a piece of our program just like this. We're going to introduce a couple of different blocks today that sort of like puts this in better perspective of like how we can actually jump from one place to another place and sort of like have a program that's written like that, right? Did that make sense?
Yes.
Okay. Okay, so let's talk about programming constructs. The term construct in programming languages is sort of like assigned to this this sort of like the format that we write different things in a programming language, like a loop or like a function or like a try-catch construct, something like that. Like this is called a while loop, but is a looping construct in this programming language, right? It allows us to this sort of like syntax lets us while loop over something as long as the condition is met. So just be familiar with the term construct in the programming languages. We're going to talk about flow control today a little bit more. I sort of like showed that flow chart to you. We have talked about branching before, but the flow control constructs are the ones, these constructs in the programming language that allow us to control the flow of this application, right? Whether we want to loop, we want to branch out to somewhere else, we want to jump to a different location, all that kind of stuff. These are mechanisms to control the flow of an application, right?
Right.
Does that make sense?
Mm-hmm.
Okay. So you could think of them as sort of like, well, let's not make it too complex. There's the other thing that I want to talk about is data or state vs logic. In a program, when we were sort of like writing a program, we're generally dealing with data, that is information, and logic, that is those operations that do something with that information, right? So like, for example, you want to say, let's say, let's give an example. Like, for example, you want to print the name of an employee. An employee is a piece of data. The information about the employee is a piece of data. It's got the name and the family name and like maybe an employee ID and a whole bunch of other stuff in it, right? And then there's another piece of logic that's purpose is to print the name. We'll pass the data to this piece of logic, and because it knows the data, it'll print the name correctly. It might not have to do with the rest of the data, but that's generally how we sort of like talk in terms of data and logic. Always
Or
think
like our example last time with the volume of a wall, right?
Exactly.
We can print the volume of the wall.
Yeah. So like, for example, if there's information about a wall somewhere, let's say there's volume and then the sort of like the base curve and the height of the wall and stuff like that, you have this as a piece of data, and then you pass it to a function that says, a piece of logic that says create a wall. And then that piece will generate the geometry of the wall from this information, right? That's literally how Revit works. You have information, and then from that, it models that geometry based on that information, building information modeling, right? So it's just data and logic. In the previous session, we talked about types, data types in sort of like specifically, like integers and floats and strings and all that kind of stuff. And I showed you that they have utility methods on them. Like a string, you can do dot lower, and it would lowercase the contents of that string, right? Data types are a little bit more complex in Python where we're dealing with, and you would see these complex data types in almost any programming language that you're dealing with. Data types usually have properties, like, for example, the volume of a wall, right? And then they also have sort of like utility functions on them that we call them methods, right? So methods and properties. I'll get to detail about this a little bit further down. Let's start playing with a little bit of these with functions and all that kind of stuff in Python, so I can talk a little bit more detail about what I mean by methods and properties being in a more complex type, right? So get it until this point, and we'll talk about that in a little bit of detail. Before I actually walk into the Python, last thing I want to talk about is composition vs inheritance. Some of these stuff are massive, big topics. I'm go over them really quickly. I'm only grabbing the stuff that I sort of like want for our communication to work, and sort of like to show you, give you a little bit of background of how things are structured and organized. You can write sort of like a lot more about all of this stuff if you actually care about it. And you can sort of like if you're learning other programming languages, you get to learn a lot more about these things. But just we'll go over these so we have a foundation, sort of like a background of why we do things the way we do things, right? There's this conversation about composition vs inheritance. Imagine I have a data type that's called a bird, right? And now I can create, let's say, I don't know, parrot, and I can say it is a bird, right? And I can say, I don't know, rooster, and that's also a bird. This is called inheritance. What does it mean is that I have something that's sort of like a generic type that defines any generic bird, and then I create more sort of like specific types as a child of that that generic parent. So they inherit the properties of the parent. Does that make any sense?
Yes.
So parrot is a bird, rooster is a bird, anything that's a property of a bird, like flying and like singing, let's say, they'll adopt.
So you can think about this like, and once again, tell me if I'm getting ahead of myself, but like wall types, right?
Mm-hmm.
Like you have a wall, but then you have types of the wall, like a concrete wall.
Yeah, or you go one level higher and say, like, we have walls in Revit, and then we have basic walls, stacked walls, and curtain walls, right? These are three different types of walls that we do, or sort of a category of walls that we deal with, but they all adopt the properties of the wall itself. In either, like, you can go up and down this hierarchy, this inheritance hierarchy of how things are structured. One of the things that's important about inheritance is that it's very structured. Like, the thing is a child of one thing, and that's it. And it sort of like adopts the properties. If you change the property of a bird, all the other birds that are sort of like adopting those properties will get affected, right? Because of this inheritance tree. So just keep that in mind. The other approach is that, hey, we're going to split the properties of a bird into behaviors, right? We're going to say we have a singable or like singing thing, and we have a flying thing.
Why not use snake case there?
Well, it's just, I'm just writing, so this is not Python. I'm just writing text.
But it's still
Python.
I mean, it's confusing, Ehsan.
Well, we'll get to it. We'll get to it while I'm not doing this. We'll get to it when we actually define custom types.
Maybe from now on you can write in snake case just so.
We'll get to that. And I can say parrot.
It wouldn't be fun if I didn't give you a hard time. So.
No, that's good. And I can say parrot is a singing thing, and a flying thing. And I can say rooster is a singing thing, but it's not really a flying thing, right? This is called composition. You have a series of basic behaviors, and then you compose these in different arrangements to come up with different things, right? Most times you kind of see a healthy balance of these two. Neither is better than the other one. It depends on the application, on like what you're trying to do, what kind of structure and data you're trying to describe. You either use the composition methodology or the inheritance methodology. Inheritance, both of them have their own pros and cons. So sort of like just have that in mind as we are going through the session, and I'll sort of like take you through the Revit API and stuff like that. Just have this in mind that sometimes inheritance approach is taken in defining new data types, and sometimes composition is taken. The approach is taken in defining new data types. Okay, I think I'm done with this piece, talking about programming constructs and a lot of these concepts that we needed to get move on to the past session. Let's talk. Move on to the next chapter. Let's actually start diving into Python and use it and create functions and new data types.
I'm excited.
Okay. So we talked about a couple of concepts, programming construct concepts. Let's jump into Python and create functions. Let's say we wrote this program to print Fibonacci numbers, but up to 100. Let's say we want to make this configurable. Like, let's say we want to print these things like 3 times in the sort of like in our program, or like multiple times, right? 2 different ranges. So there's a piece of logic in our program that does something that we want to access it multiple times, right? The old school method is that you can just copy it over to a different piece and do it all over again, right? But the problem is that your program is going to have a longer tape. Why? Because now you're repeating instructions, right? And if you had a bug in here, now you had a bug in 2 different places. Does that make sense? So if you have repeated this 10 times in your program, now you have to fix 10 different places to make sure that bug is gone. The way we avoid this is that we create functions. I'm going to grab this piece of code. I'm going to close that file. Actually, let's save this one to somewhere inside the Python and say composition inheritance, just in case. That would be a text file. Okay, let's start a new Python file. Call it second for the second session, and grab that piece of code and place it here.
And I'm in my Windows terminal.
I'm working in Visual Studio Code. You should use your Visual Studio Code as a script editor. Yeah.
Okay.
Yeah.
Sorry, you're on Mac. So.
No, you're fine. They look exactly the same. See, this is on my Windows.
Well, mine's black, so not really.
I can do that. I can do that. It makes you happier. Color theme.
Maybe it would.
Let's say dark theme. Which one do you use? Dark Visual Studio, this one?
I mean, honestly, when I downloaded it, it came like that. Probably because my windows are set up to be that way.
You can do Control-Shift-P, and it takes you to Visual Studio Code commands. It says it right on the screen when you open Visual Studio. Control-Shift-P, commands, say color theme, and then change your theme to maybe Visual Studio Lite Plus.
Do you want me to do that? Control-Shift-P?
No, you can do whatever you want to do, whatever theme that you want, that you're comfortable with.
Okay, I'm just going to leave it alone because I don't want to. Yeah, okay. But it brought up code from last time. Like it remembered.
Yeah, you remember what folder you had as your workspace. Okay, so grab that, start a second file, second.py, make sure the extension is there, and then grab the code, place it in this one. Let's create our first function. Ready?
I'm naming it second.py. And do I need to change this, the plain text, or just the .py extension will be fine?
Just .py is fine. No, don't worry about that.
Okay.
Don't worry about that.
Okay, perfect.
I think it should save as a Python file. Yeah.
Yeah, it did. Mm-hmm.
Okay. And if you click on the first button on the left side, the left bar, the first button is your browser. The one that shows the 2 papers in it. Yeah. That one. Click on it. That's your project browser. Later on, you can, just like mine, see that's my project browser that I have open here on my screen. And you just open that Pyramid Workshop folder, and you can see all the files inside it.
Okay.
Okay, don't worry about it. Let's go on. So I have this. You have the second.py folder open. We have brought the code that actually printed the Fibonacci string. We're going to turn this into a piece of function that we could reuse throughout our code, right? The way we define functions in Python is very easy. Def for defining a function. Give it a function name. We're going to call this one fib, or actually let's make it printfib, because that's what it does. And see, I'm using the snake.
Yeah. Thank you.
Case. We're going to put parentheses in front of it to tell Python that this is a callable object, right? This is a function, and we're going to place input properties for this function inside of it. So this one, I'm going to say, I want to put something that's called limit. And I'm going to end it with colons. Remember that we did the same thing with colon in the while construct, in the while loop. That's how we start a block in Python, right? So I need to move all this one sort of one indentation in, which in best Python practices is 4 spaces.
Not tab?
In Visual Studio Code, when you have a Python open, even if you tab, it'll actually create 4 different spaces for you. This is a Python practice. It's not a discussion of versus spaces versus tabs. Python PEP 8 that we talked about in the previous session suggests 4 spaces. Okay, you got it. Okay.
I caught up. I was typing it while you were talking.
No, it's good. I'm looking at your screen. Okay, so now we had defined that the range is 100 fixed, right? We need to make this piece variable. So we're going to use our input here. Does that make sense? So whatever the value of the limit is.
So you're calling for the definition that's stored within Python.
You're talking about limit?
Yeah. So like
Yeah.
you've established what that is.
Yeah. So this is a sort of like a box that with a value inside it. It's a variable.
Yeah, a variable.
Right. We use that variable here, just like A's and B's and all that kind of stuff. It's just a place. It's a box for some value.
Okay.
That points to a value somewhere in your memory. Okay. So now I have defined this program with this function that does this, right? So let's go and run our second program and see what happens.
We haven't defined what the limit is, right?
We have not yet. Very good, very good. You're very quick. So let's copy path, place that one here. I probably should rename this Python workshop so I don't have to do this every time. What did happen?
Nothing.
Nothing happened. Why?
Because we haven't defined the variable.
Well, it's a little bit sort of like it's a little bit higher than that. We created a piece of reusable code, right? But we actually never used it.
So it's not doing anything.
Yeah, this is the thing about Python, defining Python functions or functions in any other programming language. They don't get executed when you sort of like throw them somewhere in the program, because it's a reusable piece of code that's supposed to be used somewhere else, right? So now later in my tape, I have stored this on my program tape. Later in my tape, I'm actually going to call this function with a value for the limit.
Why not at the beginning?
We get to that.
Okay.
Okay, let's run the program again, and we'll see the values, right?
Okay, and
So
where are you running this again?
I'm running it inside my shell.
Inside your
terminal, yeah.
I think I had that open. Where was it?
And if it makes you more comfortable inside VS Code, actually, let me show you something in the VS Code. Let's close this one. Close your Windows terminal.
Okay.
Go to the terminal menu. Yeah, go to terminal menu and go to new terminal. Or actually, maybe there's some. Yeah, there we go. So Visual Studio Code gives you a PowerShell terminal right in there. So you can do a clear, right? Clear that terminal. And write Python 3, or like actually in your case is Python, and then copy that path and put it there. No, close that. Exit your Python.
Oh, I'll close this.
No, hold on. Don't
this.
Don't close anything.
That.
Okay, save all of that. If you want to close them. But go to, so we are working in the terminal right now. The terminal is that little window that's open at the bottom of your Visual Studio Code, right?
Yeah.
Yeah. Okay. So inside of that, Python is running in interpreter mode. So it's waiting for you to put input there after those 3 greater
Yes.
Remember that? That's your Python prompt. We want to get outside of that because we have already written our program.
Okay.
So exit, right? Type exit with parentheses. There we go. So we get.
Yeah, I remember it.
Interpreter. Yeah. Okay.
Yeah.
Great.
Okay.
So do Python again, but. Write Python again, but wait, don't enter space. We're going to put the path of the script that we have written. Is it where you have it stored?
I need to put it in quotations, right?
You can.
I can.
Slash.
It's optional.
Well, it depends on the shell, really. But you're right. Let's do it with the. There is a syntax
error.
Yeah. See, it says syntax error, unmatched parentheses in your terminal. That's the output that Python gave you because of that error that you have.
Okay, where is it?
Where is your? It tells you
Oh, it's
line
right
number.
here.
Yeah, there
Yeah,
we go.
line
It actually gives you the
9.
line number and the file that's happening in, and it sort of like prints that line for you too, and puts a little caret that points to that character. See all
Okay.
that? It's very nice that way. Okay, there we go. It
And I
works.
just hit up and enter, so it redid
Perfect.
it.
Beautiful. Okay, let's try it with another time with like maybe 10.
As our limit.
Yeah,
We're
but
gonna.
no, but
Okay.
duplicate the line. Duplicate the line.
Oh, so we leave
Yeah,
100,
yeah,
and
exactly.
then
We want to reuse it. And maybe print 10. Okay.
like that, and then save it and run it again.
Yeah, just hit Control S, yeah, and then go there, up, enter. Beautiful. See, there's ends on 89 and starts again at 0 and prints another round.
Oh, I see.
That's
So
your
it's
second
you're
line.
doing 2 tasks.
Yeah,
It's doing
exactly.
this task first and then
Yeah.
this task.
Yeah. This is one of the
Awesome.
most important concepts in programming. You modularize stuff. You create a piece of logic that is generic and is reusable. You place it inside something that's callable, like a function, and then you call that thing every time you need it, right? Not every person in the world that creates a program that prints Fibonacci numbers needs to write the algorithm themselves, right? You just use somebody else's piece of code that is already created. You call that function and it does the job for you. That's what we basically how we interact with Revit, because Revit has all these modules and all these sort of like little bundles of code inside its memory that do different things, like calculate the volume of wall, read or generate geometry, or look for walls in our model and everything else. And they have a whole bunch of inputs at their settings. We call them, we provide the inputs that we want based on their instructions, and then we get the data that we want back or get the effect that we want back, right? Does that make sense?
Yeah.
Okay, so these, you can think of these as if you're playing with Dynamo or Grasshopper. These are, each one of them is like a component. It's something that you throw in there by itself. It doesn't do anything, but once you provide the inputs to it and actually call it with some inputs, it'll have some effect for you. Did it make sense?
Totally.
Okay, so this is basically Python functions. Fairly simple. One thing that's really important here is that it's called scopes, and the sort of like I'll answer your question about why we're not putting this print before this function, right? So if this is this is the tape of our program here. Look at this image. If this is the tape of our program, these are little blocks that are sitting inside of it, right? The blocks are indented. So if we go back to that example of the flowchart that we looked at, this flowchart, think of those blocks as one of these pieces here, right? They look like they're right after each other, but logically they might not be. Does that make sense? Mm-hmm. We define things, but the way the program moves around with different instructions, moves the tape around and moves to these pieces, different pieces, is how sort of like the program actually gets executed. Whatever we write here without indentation is called the global scope. It means that all these different blocks in our program that we define have access to all the variables that we define here. So let me give you an example. Let's define name as Dana here, and I'm going to create a different function, print name, and I'm not going to provide any variable to it, any inputs to it, but I'm going to say print name. So see the name, we haven't given it as an input to the function. It's here, right? But if I actually use the print name in my program and go run it, it'll print Dana. Why? Because it is a block, part of this program, inside the global scope of this program, so it has access to all the variables that are defined there. Mm-hmm. Does that make sense?
Yes.
Okay. So what if I say print A? We have defined A here with value of 0. And I'm going to run my program here. I'm going to get a name error from Python that says, hey, I don't know what A is. Name is A is not defined. Why? Because A is defined in the scope of this function. Python has this nice visual representation of scopes. Everything that's indented defines a kind of sort of a different scope, right? So this A is only valid inside this print Fibonacci.
So why do you use the terminal? Why not use the terminal? Why do you use PowerShell?
I'll get to that in at the end of this session. That's a big conversation that we need to have.
Okay.
It's a big conversation about on operating systems and how programs get executed. I've added sketches and stuff like that. We'll discuss it in detail at the end of this session. What is any part of this confusing you?
No.
Why are we doing this? Does that make sense?
Yeah.
This scope thing?
I think so, yeah.
Okay, so if I use the name here, would that work? Like if I assign Ehsan to this and then print the name here?
I figured it would because you've already defined it.
Okay, let's take this as an example. I'm going to run print Fibonacci first. Inside of this function, I'm going to assign the variable to name as to name, the sort of like value Ehsan to the variable name, and then I'm going to print the Fibonacci numbers. I'm going to come back from this piece of logic back to here, go to the next function, next, and print the name.
Yeah, and it called Dana, which is what the first definition is, which is kind of what I expected it to do.
Okay, but we called this print name after print Fibonacci.
I see. So in your logic, because you're calling a task after the print Fibonacci task, you're saying you should have already read all of that, so the definition should change?
So here's the thing. If you're working in Visual Studio Code and you have the Python interpreter selected and stuff, I don't know if in your case it does it. Let me actually look at your screen. I don't think, no, you haven't written the program yet. But basically, if I hover over this, it tells me that redefining name from outer scope. We talked about scope. Outer scope means a scope that's one level beyond or a couple of levels beyond this scope. In this case, it's here. It's the global scope, right? So it is telling you that you have defined the name before, and inside of this, you're redefining it. Right?
And why would you do that?
We'll get to this, why we want to do this later. These are the stuff that we want to avoid generally in our programming languages. We're not going to get, in our programming, we're not going to get into too much detail about this because sort of like the conversation about scopes goes very deep and sort of like it's very confusing. But I want to, at this stage, I just want you to be aware that these names and variables that we define, they have limitations on their scopes, and they behave differently depending on the scopes. We'll talk about the advanced Python concepts later. Just know that just because you define the variable A here doesn't mean that you can use it anywhere in your program. Right? I showed you two examples, one that worked and one that doesn't work, and we'll get to these sort of like the details of this later. Yeah. So that's namespaces that we'll also talk about. Okay. Any questions, Dana? Let me actually go through the questions. On the chat, to use a way to visual writing your file path every time you run your code.
Suppose, Tim, and this creates a good break for a chapter.
This error. Character this error file style. Character. This is the idea of global vs local variable. Yes, Bjorn. This is the idea of global vs local variable. Yes, we are talking about scopes, global and local scopes. Okay. This so many times that
I'm gonna wait until maybe you go into further explanation to make it maybe a little bit more clear.
Okay. Initially, I've had it
or a little over halfway through, just so you know.
Okay. Halfway through the session?
Or almost halfway through.
Okay.
Yeah, it's almost 6 here.
Okay, so I might have to cut down a little from a little bit of this. Or we can move faster.
Yeah, let's move a little faster until we get to the actual beef of the Revit API.
Okay, let's not talk about the creating custom types. Let's not talk about this. We'll just talk about namespaces and modules. Okay, we talked about scopes. Okay, so in this section, let's talk about namespaces and modules in Python. We created a function in our previous sort of like attempt. We created a function that does something, right? Now, I want this function to be reusable in my program and in other programs as well, right? So maybe I'm writing a different Python program later on and I still need function. In this function. What do I do with this? This is the concept of modules. And modules have this really important thing associated with them. The concept that's associated with them is called namespaces. Namespaces are scopes for a series of names. So now we kind of know what a scope is. It's sort of like a boundary of like things that are contained inside it. They either are the part of a bigger scope, or they can have multiple little scopes inside of them, right? Namespace is a sort of like a scope for a series of names. For example, let's say I want to define the family name. Let's say every person in the world is called every person in the world, or you have a lot of different people in the world called Dana, right? This is not a unique identification for these people because they're all called Dana. That's why we came up with the concept of last names. So we associate another piece of this information with them to provide more variety and sort of like be able to create more unique names. So within the Filippi family, they might be like one Dana only. And within the Iran-Nejad family, there's only one Ehsan, right? So Iran-Nejad is kind of like a namespace. De Filippi is a namespace. And inside of that, we might have a Dana Iran-Nejad at some point, right? But these two Danas are different from each other because they're sitting inside different namespaces, right? So I can have a namespace that's called printing, and my print Fibonacci function is part of that namespace. And I could have another namespace called something else, and I can have the exact same name for that function inside that namespace too. Namespaces are a way for us to be able to reuse a name that we like for something that we want to do, but under different namespaces so we don't have conflicts. And I'll show you what this means. I'm going to create the second program that we wrote. I'm going to modify this so it uses this print function from an external module, right? I'm going to create a third file here, call it utils, as for utilities.py. And I'm going to go grab my function and place it here. I'm going to save this. I'm going to save this. Now, in my original second.py, I'm going to say import utils. And I'm going to come here and say utils. That's my namespace. That's like the Filippi dot printfib 10 or 100. So I imported this inside my Python script.
And what's in utils? The Fibonacci. Okay. Mm-hmm.
Does that make sense? So now
Yeah.
I'm using the function printfib from the namespace utils, or the module utils. And if I run the program, it'll work. Right?
And so within Python, they understand calls between other Python?
So when you call this,
because you imported it.
Yeah. So when Python is running your second py, it's actually going to go load this up and brings it inside your program tape and places it somewhere. And remember where it is placed. So when you actually call it, it'll go there. Does that make sense? So you don't have two Python programs running.
But why didn't you need to use like the file path? Why can you just call it utils?
Because Python, there's a Python convention. Python can find this utils.py file if it's right beside that second.py. And we have more complex ways of creating Python modules too. We'll get to those later. Does that make sense?
Mm-hmm. But they
Because
kind of like need to live within the same folder.
Yeah. They
For
need
it to be called this way. Okay.
Yeah. It's like it's got a side-loaded module, a sidecar module, right? So it's right beside that script. Because Python is running and you ask Python to import utils, it'll look into the same folder and say, hey, there's one that says utils.py. So it must be that.
Okay.
And it imports it here. If I go rename this to print utils,
it's not going to work.
It's not going to work anymore because it won't find it. So now I have to change this to print utils. Oops, that was a mess. And it works again. Does that make sense?
Mm-hmm.
Okay. Okay, so remember modules as a way of collecting a series of functions that we have written, because you're not limited to putting this function in. You can put 1,000 functions in here, right? Each doing
like a library. You're like calling a library almost.
Exactly. It's a library of utilities and tools designed to sort of like work within whatever they do, and then you import it in your program and you keep using it, right? Generally, always keep this in mind that, hey, whenever you're grouping these libraries, put them on in a namespace that makes sense for them. Like if this module is called print utils, every function, every logic that we're gonna make a decision and put there should be about printing, right? Python is not going to stop you if you want to put other stuff in here, but it's going to make other people's life a lot easier when they're reading your program because they see print utils and they understand that these are utilities for printing. Does that make sense?
Mm-hmm.
The naming modules, always remember, naming modules is really important, and the way you sort of like throw stuff in the module and sort of like combine these different functions in a single module or a library, you kind of want to have all of them have the same kind of a scope, same kind of use case, right? They're similar to each other, to what they're trying to do. Okay, let's look at take a look at really quick. Take a look at a couple of questions. I'm confused on how you understand what directory to look at. Python, we gave the path of that file to Python, so it exactly knows where the file is placed, and it can look at whatever that's inside that directory as well. That's how it finds the other file. Okay.
Would it not be unwise for you to do import and the actual file path and file name? Like
you can. It won't accept it.
It won't accept it.
No. It's got mechanisms to add new search paths, what it's called. So you can define the new locations that you have placed your modules to your Python. So when you say import print utils, it'll search all those places and find the print utils.
I see. Okay.
We'll get to these when we actually start playing with Revit API. Okay. How are you feeling?
Good.
Okay. There's a very famous module in Python that is called this. So if I open my Python interpreter, I'm just going to call it on command line and say import this. It prints the Zen of Python for you. Take a look at this when you have a free time. It's the sort of like manifesto or like the mentality behind designing the Python. Like, for example, simple is better than complex. Complex is better than complicated. Flat is better than nested. Sparse is better than dense. Readability counts, stuff like this, right? Take a look at this. This is kind of fun. A lot of Python programmers actually follow this to heart. Okay, let's talk about API and Revit API. API means application programming interface. It's basically a collection of logic that do something for you. And then if it's called Revit API, they're all Revit related, right? It's basically just a library or a collection of libraries that provide you some sort of logic that you can work with, right? We're going to use the website that is called API docs, created by my good friend Guy Talarico here. He had created another one that's called Revit API docs, so that's kind of the same if you want to work with that too. But API docs has Grasshopper and Rhino Comment and Navisource and stuff too. I'm kind of more used to the API docs. You can use either of them. The beauty of this is that you have access to the API documentation for a lot of different Revit versions, right?
Did you know Guy is from Washington, D.C.?
Yeah, he studied there. He's Brazilian, but he studied there. I think he's met his wife there too. I don't know.
Yeah, bro.
Okay,
Yeah.
so let's make this one bigger. And when you open the documentation, this is the piece that explains how Revit API works to you, but it's not like a tutorial. It basically is a list of all those little logic pieces sitting under different namespaces. See, it says namespaces. Like Autodesk was the main module, and there's inside of it is another library called Revit. Inside of it, another library called Application Services. Right? So it's a nested structure of libraries. Each one of them is grouped based on what it does. There are two major groups, Autodesk.Revit.db, which is everything that deals with database, and Autodesk.Revit.ui, which is everything that deals with Revit UI. So if you're looking for how to create buttons in the UI, you want to look under the UI namespace. If you're looking on how to create a wall or read the property of a wall, it would be somewhere inside the DB namespace, right? And you can see like analysis, architecture, electrical, fabrication, IFC, mechanical, plumbing, point cloud, steel, structure. Like they're all sub modules inside the DB module because they're all deal with the database, the Revit information in a database, right? Make sense?
Why aren't the descriptions filled out?
Well, you kind of click on each one of them, and there's a whole bunch of stuff inside.
Oh, okay, there's the description.
And
Well,
each one
did
of
you
them
see how before it was, like when you were up on the namespaces, like the higher level, it didn't really have descriptions filled out.
Oh yeah. So this is like this documentation piece. You kind of have to, you'll go through it. It's a massive documentation piece, right? There's so many different things in here. Like for example, let's search for a wall. For wall class. We passed over creating data types, but this is a custom data type, just like integer and float and string. This is a custom data type that Revit has defined that wraps a wall object in Revit, a wall element in Revit, right? We can see the methods, which are the utility functions, just like the two lower and title case and uppercase that we saw with strings. These kind of stuff in here, and you can see a set of properties, like the volume. Like this one, we can't see the volume, but the width is there. Whether it's flipped or not, it's there. Orientation is there.
And so a method would be like something you can do to the wall.
Exactly.
And the property is obviously
also,
data related to the wall.
And you said it also right. And remember that as you are becoming a better and better programmer, a method is something that does something to that data type.
Okay.
Right? You good so far?
Yes.
Okay. Does the concept of API and how this is structured make sense now?
Yes.
Knowing the modules, knowing the data types and all that kind of stuff?
And it's super important to know this, right? So that you're not calling for every library at the beginning of your Python if you don't need
Very accurate. Very accurate. This is one of the most important things in programming, that don't bring in something that you're not going to use, because you're just going to make your program more complex and harder to deal with. And then you're going to have conflicts and all that kind of stuff. Right? Okay. So let's actually create a program right now that is collecting a series of walls from Revit. And then we're going to use some of the Python modules, the series of standard modules that Python provides for us for convenience, to write that information to a CSV file. How does that sound?
Sounds good.
Okay.
So a few questions. Is there an up-to-date tree picture with all the namespaces, classes, and methods that you've seen? Thomas says that he's seen an old one, but he hasn't seen one that's up to date. Like a tree picture that shows what all the namespaces are.
No,
I guess it's kind of what I was asking. Like, it doesn't have the descriptions filled out. It would be kind of nice to know from like a higher level perspective what each one of these does.
Oh, each one of the namespaces? Yeah, the namespaces don't have any explanation as far as I know. Let's click on one of these and see. Yeah, it does just list the classes.
Right.
And as you program more and more, you kind of understand. Like Python actually does have this. I don't know if C#, the language that's been created to generate this API, has that option or not to sort of like provide description for namespace. But Python can do that, and we'll get to this in later sessions. There's another question that's sort of like similar to this. It asks Python vs Revit API. As far as programming languages, the API is not in Python, correct? We'll talk about this stuff later in later sessions in more detail. API, the Revit API is created with C# programming language, and it runs on the common language runtime, which is the .NET platform. So it's sort of like tied to these. Just take this for now. These are very complex subjects. We'll talk about this in more detail when we're more familiar with how programming languages actually work, and like how operating systems work and all that kind of stuff. Okay, let's write the program that we want to write. I'm going to close this. I'm going to minimize this, open my Revit. Whoops. Open my Revit, and in Revit, we talked about in the preparation session, if you have Revit Python shell installed, open your Revit Python shell. We're going to use this to access Revit API. So you can see, okay, so you can see on top of this window, you can see a prompt that's very similar to the prompt that we have been using so far. See Python, version, some other information, a little bit of instruction about how to getting help and stuff like that is exactly the same. The project is exactly the same, right? But instead of Python,
except you just don't
run
need
Python.
to type Python. Okay.
Yeah. But it says of Python, instead of Python, it says I run Python, right? Python that we use is created in programming language C. This one is created in programming language C#. Why? Because it can easily talk to Revit API, which is also written in C# programming language. Just take this for now. Don't worry about it too much. We'll talk about Python specification and implementations later, right? Okay. As far as we care, we're using Python 2.7. Got it?
Yep.
Okay. So you can use any other Revit sort of like Revit version that you have, but I have Revit 2020. You can use that. The APIs are actually pretty similar. There are differences between them, but in these sort of like workshops, we're not going to do anything that's crazy enough that sort of like has a very varied API. Okay. So what if I say import, because I want to import a module, autodesk.revit.db. It worked, right?
I don't know. It didn't give me a message that it didn't.
Okay, so we actually imported one of those namespaces. Now, here's the thing about import. This long name, we don't want to refer to this every time we access the namespace. So we're going to use something that's shorter, as db. Right? Or in a different way, you can say from, and these are all keywords. See, it says turns into green. From the namespace Autodesk Revit, import db. Both of these work. I prefer this one because it's more Pythonic, I think. Right?
Okay.
So what we did is that we bring the db in here so we can refer to what's under it very easily without having to write Autodesk blah 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 every time.
Okay.
Right?
Got it.
So we imported one of these modules that is provided by Revit for us, which is the Revit API, to do something. Got it?
Got it.
Okay. Revit Python shell does a few things for us, like setting up the variable doc. In more advanced sessions, we'd actually get to it of how this doc is set up, but just know that once you open Revit Python shell, there are a couple of variables that are already set up for you, so it can work easier, right? Does doc on yours work?
Yeah. Well,
Okay.
I got a weird syntax error, though. I guess because I'm calling for it, but it doesn't look like you did. Do you see my screen?
Yeah, why does it say? No, from. You don't see. Look at my screen. It says from Autodesk Revit.
Oh, I see. I messed up there.
Yeah.
Okay.
It's kind of like Python is like English, like the way you kind of
But it
write
doesn't
it.
matter. I called it a few times, right? I mean, for all intents and purposes, it's called.
And you can do up right now.
Yeah.
You want up? There we go. Go back to it. Fix the or come back one. Fix the import to from, and then hit enter.
Okay.
There we go. Okay.
Yeah.
Okay, so you have DB in your global scope of your program right now, in your tape. We brought in the DB, and we already have doc defined for us by Revit Python shell. That's one of the nicest thing about Revit Python shell. Cool?
Cool.
Okay, so we have access to document. When I sort of like write doc in here, it prints the description of what doc is, and it says it's a autodesk.revit.db.document, right?
Mm-hmm.
Let's go through the API and look at this thing. Actually, I'm gonna go use my Windows document class. Okay, document. Where is it sitting? It is sitting inside Revit 22 API, and the namespace is Autodesk Revit.db. So it's the exact same thing that we saw there, right? We're gonna look at the properties. See what do we have here. Oh, there's something that says title. So let's print doc.title. It's project 1. We just read the name of that document. Now, what's really important here, this is a document that's open in Revit. We're not talking about a Revit model as a file, right? We're talking about a file that's been opened in Revit, and Revit has read the contents of it and is giving us a sort of like a pointer to it that points to that document that we can use its functionality and stuff like that. This is different than the actual Revit file, right? Just keep that in mind. Cool? Beautiful. Found the active view.
Yeah.
Yeah.
I went rogue, sorry. And I
That's
know
fine.
my screen is
That's
probably
fine.
confusing.
Tell me what is the type of the active view?
It's a view plan.
Okay, go find the view plan in the documentation and tell me what properties it has.
Okay, hold on. Let's get API docs open here. So I'm going to look for active view property.
Yes, the active document. You might have multiple documents open in Revit, but this doc is to the active one.
So document properties,
Okay.
active view
Okay.
properties.
Okay, go to the right side. No. Stay, don't scroll. Scroll back up. Scroll back up. See, under syntax, C# says public view, active view, right? That's the active view is the name of the property. Its type is view right there. But you're looking, what you saw is view plan.
Right.
Right? View is like the bird that we talked about. View is a general category of different views. All other views like view plans, view reflected ceiling plans, 3D views, they're all children of view. They all sort of like adopt the basic properties, right? So now in the search term, look for view plan in the search box. View plan class. Perfect, that's first one. Okay, click on it, see the properties. Those are methods. Properties, yeah, okay. Okay, great. So you can see the view plan, right? Now go to the right side, the right panel, and scroll down to the bottom. You should see a hierarchy of these. No, scroll down way to the bottom. Actually, you're clicking on view plan properties. Click on the view plan class on the left panel. Yeah, and scroll down to the bottom. Okay, no, go back up, go back up, go back up, back up, back up, back up. Okay, hold on. See, it says too much. Look for the inheritance hierarchy in the title.
There we go. Here we go.
See, it says system object, then DB element, then DB view, and then DB view plan. That's the hierarchy, the inheritance hierarchy that we talked about. System object is the ultimate generic object that everything inside the C# or .NET environment is a children of. And then you have DB document, which is inside Autodesk.db, Autodesk.revit.db. This is specifically a Revit API thing, right? It's an element, it's a generic element. A child of that is view, and a child of that is view plan. Now click on the view. It'll take you to the view class. Open that and look at the properties and find the name property. So view, actually there's one that says view name, I think. You can find it in the left panel too. Right panel has a view description. Okay.
Maybe it's just name.
Yeah, it's either name or view name. It's not there.
Title.
Well, title Title works too.
Okay.
Or like we can use any of these. Like let's use the title. If you go back to the view plan, you won't see title listed there. But now go back to your Revit Python shell and print doc.activeView dot ActiveView dot title. See, the title's there, right?
Mm-hmm.
Go back to the documentation and find view plan. Just search for it. There we go. And look at under the properties. Does it have a title property?
Parameter property.
No. Under the view plan properties, do you see anything that says title? On the left panel. No. Right? Now look at on the right panel. Go and find the title there.
Name.
No. Go find the title, the same thing that we used.
Title.
Okay. What says in front of it? There's a description, and then under the description, there's something in parentheses. It says inherited from view.
Mm-hmm.
That's what it means. That's what inheritance means. Title is a property of view, just like flying was a property of a bird, right? It inherited that property from that view. So now every other view type that inherits from Revit, inherits from view, has that title property. We'll play with this a lot. So just take the basic concepts right here. This is a sort of like a more tangible example of inheritance. Got it?
Got it.
Okay, let's draw some walls in the Revit model.
Yay.
Mine is weird. Okay.
Oh, like you actually, I thought we were going to do it in Python, but okay. Yeah,
Oh, no. Well, creating stuff is far
much harder than modifying. Got it.
Okay, I'm going to create a bunch of them so I have different volumes and different lengths and all that kind of stuff. And different widths and whatnot. Okay, ready?
Yeah, I'm ready.
Okay, so let's go grab volume and width of this wall, and we'll print those properties into the output. Okay.
Okay.
Okay. So open Revit Python shell. The first thing we want to do is that we have to collect the walls in our Revit model, right?
And yeah, and first we have to collect the DB, right?
Import the DB. Yeah. Great thinking.
So
I think it's already
from.
Huh?
Oh, you already imported it, remembers?
Well, it's already, that's one of the nicest thing about RPS. RPS kind of sets up that for you. So you should have DB and doc already defined. Do a DB. Oh, you don't. I do have it. Okay, don't worry about it. Just say it from Autodesk something, import that. Revit.
From Autodesk, Revit, import DB.
Beautiful. Okay.
Yay.
So we're going to use Revit API functionality that's provided to us to collect all the walls in our model, right? So we're going to say walls. We're going to store all the a list of walls inside this variable. We're going to say db dot filtered element collector. We're going to pass document to it because we want this filter collector logic to work on our document.
Okay.
Right?
Yeah.
Right? Okay. Of category. So what happened here? We use the DB. Under that, we use the filter element collector. We pass the document to it. Whatever comes out of this calculation, you can see it kind of looks like a function, right? Like a function name and the way like we call the print function and stuff, right? It kind of looks like that. It will return a value. The Python will evaluate this and will replace with whatever came out of it. And whatever came out of it, we'll call the off category method on it.
Okay.
Okay. And off category, we say db built-in category OST walls. Whoops. OST underscore walls. So you can see.
What does that all mean?
OST underscore. Yeah. Yeah. That's something that's weird that RPS does. It kind of like automatically selects one of these walls. Beautiful.
Okay, so I just need to type it. Okay.
Underscore wall.
Underscore. What is OST?
I knew it at some point, but I don't remember it right now.
Tim?
It stood for something. Yeah. Okay. So it got you sort of like you're seeing that it got really long and weird really quickly. Right? That's one of the things that you get used to as we're working with .NET applications. They have very spelled out names just because they want to be as readable as possible. And there's a lot of nesting.
You spelled category wrong.
Oh. Man, you're already the second session, you're taking my errors, huh? You're finding my errors. Okay.
Shout out to the chat.
The off category, we're passing an input to it. We want to say filter all the elements in this document that are off the category OST walls. This is way of this sort of like Revit API provides to us this selector that has the sort of like the names of all the known built-in categories already available to us. So that's how we specify. That's how we communicate with the Revit API. We have to talk to it in its own language, right? That hey, you told me that this is a wall. Here, find me all the instances of this. Does that make sense?
Object style.
What are you talking about? Okay.
Object OST.
Okay.
Object style.
Oh yeah, you're right. Yeah. OST was object style. Yeah.
Or original soundtrack if you Google it.
That works too. Yeah, that works too.
Okay.
Obviously sensitive topic. What? Okay, 2 elements.
Well, it just helps me understand what the heck I'm doing, I guess. I don't know.
Makes sense.
Why?
That's good.
Why
That's good.
OST? Like it.
Yeah, object styles. It is. That's it.
Object styles of walls.
Okay, and we want to do. Okay, go back up. You entered too quick.
Okay, well, hit up. Yeah. Okay, here.
Gotta go into your. Yeah, there we go. And then add 2 elements at the end of it. .2 elements.
2 elements.
So once we collected everything, we're gonna tell Revit API that gives us all this information that you collected as elements, right?
You can see how excited I'm getting. Like I've hit enter like 3 times when I shouldn't have.
Okay, so we're gonna loop over these walls. So let's just type on walls. You see it says list element, and then it has a whole bunch of stuff in it. Series of walls. Right?
So at the document, we have the object type 0 to
There's a list of, see, they're all separated by a comma. It's a list of stuff in it that each one of them is a wall, a db.wall.
And I guess these are somehow like
they're memory addresses.
Sorts. Okay.
Yeah, they're memory addresses. Don't worry about those.
Okay.
Okay, got it? Okay, so we want to loop over this right now. We have a list of stuff, just like a list of fruits that we looped over, or a list of names that we looped over when we were talking about loops. We want to loop over these walls and print a single property, which is the width of a wall out of that, right? Mm-hmm. For this, we can use while that we wrote before, because while requires a condition. We don't have a condition here. We have a list of stuff that we want to loop over. We're going to use the for. That's a new thing in Python that you're learning. We're going to use the for loop construct. Say for wall or for w or for whatever the name of that variable you want to be in walls.
Wait, for w in walls, what are we calling? What is the w?
Let's write it, and add the semicolon and the colon, and I'll tell you what this is. Okay, so what this does is that it goes into the walls list, grabs first one, puts it into the w, which is the name of your variable. You can use anything else in there. Right, but a short name like W for walls kind of makes sense, or you can get it type wall there, and then enters the loop. So I can say.
So it's like for wall instance in walls.
Exactly.
Okay.
Right, for wall element in walls, 1, 2, 3, 4 spaces. Print W dot width.
Okay. 1, 2, 3, 4 spaces. Print width.
No, not width.
Oh, W. Yeah, because we want the wall instances width.
Yes, exactly.
Okay.
And the width is
Got it.
There. Another enter.
Why 2 enters?
because
Oh, because like finish the task. It's like
Finish the
asking
block.
for more calls.
finish the block.
Got it.
See, when
Yeah.
your command prompt has three greater than signs, once you enter the block, it writes 3 dots. Look at the for loop on your screen. You can see before the print, there are like 3 dots. It means that you're inside the block, because Python understood that 4W in wals and expects you to be in a block right now. So it expects you to do indentation. Got it? If you don't do indentation, it's gonna show you an error. So what we did is
and
that
this is looking at the wall type width. Yeah, so like those elements, not the instances. So like the actual types. Got it.
What do you mean by type here? This is the part that we talk about types in different contexts, so Revit types or programming language types, and you have to be sort of like more specific. Are you talking about a Revit type?
Yeah, Revit type.
No, the width is reading from the actual wall, the width of that wall.
Yeah, I guess I'm like the types versus instances, I guess is what I'm looking at. But it has to be types. So it's a type definition based off of the wall.
The width is a property of the wall instance. Its value is calculated based on the information that is defined in the wall type. Got it?
But we're looking at wall types. Right, like if
the walls that you drew, they all have the same type, right?
Yeah.
So why the width of one of them is different?
But it's just weird that I'm looking at I'm looking at Teams and it's showing my screen maybe. No, it's not. We have the same width, so it doesn't make sense. It has to be types.
Okay, but they all should have the same width, right?
Okay, but yeah, but the instance inherits the types. Yeah. Okay.
Okay.
Never mind. So, let's move on. I get it.
Let's address the fact that we drew walls of the exact same type where we are seeing different widths. Right? One of them has a different width. You see that on your screen too, right? 0.08333. One is narrower than the other one.
Yeah.
Okay, let's talk about that. Let's go back to our walls, the collector piece that we collected the walls. This is why we always want to add this here, where element is not element type. See, when I printed the walls list before, the first one is a DB wall type, and the second one is also a DB wall type, and then the third one is a DB wall. Types and instances are represented differently in Revit. DB wall type represents a wall type. DB wall represents an instance of a wall. We have 2 wall types defined in this empty model, and in my case, I have 6 wall instances. So I get 8 outputs: the width of the first wall type, the width of the second wall type, and then the width of the 6 instances that I have that's following the first type. Does that make sense?
Can you say it one more time?
Okay. Look at the walls list here.
Okay.
In my screen.
We have this. Yeah, I'm looking at your screen.
Yeah, look at don't confuse each other with your screens. Just look at mine. Walls. What's inside it? There's a DB wall type. There's a comma. There's a DB wall type. Comma. Oops. Comma. And then there's a wall. And everything else after these is also walls. So I got, in my example, I have 8 elements inside this wall list. The first 2 are wall types. The other 6 are DB walls.
Okay.
Right? I'm just going to grab all of this stuff because I have to rewrite them again. Let's copy that over. I'm going to close mine. 1, 2, 3, 4, 5, 6. Look at here.
Do we just like happen to draw the same amount? No. Okay. I do have one additional to you. Okay. Sorry, I
Okay,
was
yeah,
just checking
no
my list versus yours.
Okay, so this is my wall. Look at mine.
Okay.
This is the wall instance, right? That's instance of a wall. Edit type. This is the wall type.
Mm-hmm.
This is represented in the API differently than this.
Mm-hmm.
As if I change the properties of this, all these walls are going to get affected that follow the same type. If I change the height of this, only this is going to get affected, right?
Yeah.
Okay, keep that in mind. Make sure always when you're collecting instances that you are saying where element is not element type. I think I wrote it correctly. I'm writing off of memory. Elements. Yeah, it works. So now let's take the length of the walls element, walls list, and we have 6 now.
And then print.
Print.
Do I still need to do the call for it remembers it, right?
To what? No. What are you doing?
Oh, you did length.
Length of walls. Okay. Now you have 8 walls. The walls that you drew, right?
Mm-hmm.
Okay. So now let's loop over them again. For W or for wall in walls. Print wall dot width. So I have 6 walls all matching the exact same width.
Okay, and I just use W. That's fine.
That's
right?
fine. That's fine. That's just a variable name. Just like A, B, or C, that's just a variable name that you create inside that for loop. Got it?
Yep.
Okay, beautiful. I don't. How much time? How much more time do we have?
We have 30 minutes.
30 minutes. Okay, so let's do another 10 minutes on this. We might not get to writing the CSV, or I might just show you really quickly. And then let's just print this time, and I'll show you the Python default modules, and we'll talk about one of these modules later, so we can get to these stuff. Okay, so really quickly, we got the elements collected, and we got looped over them and printed the width, right? So now I want to create a function. I want to create a function, and I'm going to use it here. Use the bottom of that RPS. This is like the top part is like Python interpreter. The bottom part is like a Python script that I'm writing. Def collect or like get walls in the document. I'm going to use D for it, colon. I'm going to copy all of this, and I'm going to use the keyboard. Sure, I'm going to use the keyword return to allow my function to return a value.
Do I have to like copy this a special way?
No, you can. Yeah, you can use. Sometimes it's clunky to use Control C. You have to use return at the start of that line, and then change the doc inside that line to D, because you want the variable, the input of that function to go there, right?
Okay.
Okay. Now hit the play at the end of this, the run script at the end of this toolbar.
Or F5.
Or I guess F5. I don't know. I've never used F5. So when I say get walls, doc, it'll return the list of walls for me. Did that make sense?
No.
We created a function just like other functions created. Which part didn't make sense?
I guess I'm getting confused because the terminal, it seems the opposite from the Visual Studio terminal.
Yeah, it's okay.
Okay.
I'll explain those stuff. That's why I want to spend 20 minutes explaining all of this, because this is one of the first things that confuses a lot of people. But you get the function call, right? The Python function call. We created a function that we call. So this is how you can create your own modules. This is called wrapping. You create a series of functions that are useful to you. Like, for example, you get to collect walls.
So this is like when you created the print utility and
Exactly.
you called the print utility.
Exactly.
You just created a definition to get walls from the database.
A function, not
and then within and then within the top you called for it.
I call the function.
So why would you do it at the bottom?
Well, don't confuse yourself with the terminals right now. Let me get to the 20 minutes that we're going to spend talking about this.
Okay. Yes.
You sort of like stay on the Python side only.
Okay.
The function call is clear, right?
Mm-hmm.
Okay, so now we can say walls equals get walls duck, right? And then inside of the walls we have all the walls. Right? Python sees the equality, the assignment. Sorry, not the assignment. Processes the right side of it because that's where the value is. Calls the function, passes the document, does the logical computation, whatever it needs to do, grabs the return value, places in there, and then assigns it to the wall. Right?
Got it.
Okay,
Yep.
so to make this simpler, we can say for wall in get walls doc print wall width. Right? So we eliminated one walls variable that we're not going to use anymore. We just placed it inside the for loop construct in the place for that walls variable. Does it make sense? So you're getting this idea that the program in the Python is seeing these different pieces that you place in your programming language. It evaluates them, replaces them with the values or the results, and then goes about executing the rest of the script, right?
And it's essentially you're just like creating a shorthand.
Exactly. You're just simplifying things because it reads well. For wall in get walls at this document print wall width, it reads very well. Right? This is one of the most essential concepts in programming. You have to write programs in a way that's readable to other people. So as they read your program, they can understand what is trying to do. Got it? Okay.
Yep.
That was your first API, Revit API. Playing with the Revit API reach. You collected a bunch of walls and got their width values. Now you could in your loop you can maybe collect all the widths or sum up all the volumes. You already know that much. You know how to add stuff together. You know how to create variables. You can create a variable that's called total volume and then go loop over your walls and calculate the total volume of all the walls in your model. Got it?
Yep.
Okay. We'll have to talk about a lot more stuff after this, but to end this session, I want to talk about operating systems, the command line interfaces, GUI or graphical user interface applications, and stuff like that. We get to that in the next chapter.
And does it report this list based off of the element ID? I guess it wouldn't be based off of the creation because we didn't create these types. They're in the template. So it's just based off of like their internal GUID. It's reporting them based off of that. The order of the list.
You don't have any control over the order. Revit returns that order. Right now, it's based on the element ID.
Right.
Unique number that's associated with that element.
Yeah.
Because they're just big integers, and as you add more elements to it, they'll show up. They'll sort of like that number gets increasing, but it's not guaranteed. You shouldn't really depend on these kind of stuff. If you need your walls in a very specific order, you should sort them yourself using your own logic. So they're always that way. Okay. One of the biggest problems that sort of like brings bugs to the programs is assumptions. A lot of times you make an assumption about an application, and that assumptions will bug you later, sort of like, and create trouble for you. Yeah, Mark wrote a piece of Python program that prints the ID, the integer value of that walls. So you can do that. Yeah, do a loop, print wall dot ID with a capital I. Perfect. So then this number, this integer, is the unique idea of that. Is the ID of that element. And you can use this actually to select that inside the Revit environment too. There's a button inside on the manager, I think it's called select element by ID or something like that in the Revit interface that you can give it the ID and it would select that value for you. Okay.
Awesome.
Yeah, let's talk about, in this section, let's talk about operating system basics and how applications are actually executed on an operating system. So the first thing that I want to talk about is what is an operating system? An operating system is the first piece of program that runs on your machine when you start your machine, right? There's a lot of details into this. Just remember this as sort of like general theoretical concepts. You have Mac OS or Windows installed on your machine. You fire up your laptop or your tower or whatever, and sort of like you hear beep, and then after that, your operating system kicks in, starts looking at all the peripherals, all the devices that are connected to your machine, your graphics adapter, all that kind of stuff, loads special pieces of programs that are called drivers that know how to communicate with that piece of hardware, and the operating system knows how to communicate with that special piece of software, right? So the operating system talks to the mouse driver, and the mouse driver knows how to talk to mouse, right? To your attachments. So it sets up this environment for you, and then it launches something that we call a window manager. This desktop environment that I can see with the windows and stuff, it's called a window manager. Its job is to manage all these windows, right? We call it the desktop environment in general, or like as a Windows user, we're very familiar with the sort of like just calling it desktop or Windows Explorer, right? There are two different applications. There are two ways that we can run applications once we are inside the operating system desktop environment, right? We are inside this desktop environment. I'm going to minimize everything that I have here. This is my desktop environment. I have a couple of buttons in here. Your Windows is very similar, different ways. In Linux, it's a different way. They're all different window managers, right? A window manager is sort of like an application by itself. It doesn't have anything that we can interact with. The interaction happens through these buttons and the sort of like the top bar and a couple of menus and all that kind of stuff that are there, right? Just know that this desktop environment's job is to manage the windows and then show you the taskbar and the icons and all that kind of stuff. Cool? One of the main ways that we're used to running applications is using their sort of like icon and clicking on the icon to get the GUI application here. This is a GUI application. It's graphical user interface, right? There is a piece of logic sitting behind this that does the work for us whenever we interact with this piece of graphic. When I click on a button, click on a selection here, like all the other stuff, those pieces of logic that are part of this tape of this application gets executed, right? So when I click on my videos, there's a function inside this tape that says shows or like pull my videos or like show my videos in the UI, right? And when I click on this, that gets called and the list of the videos will show up. Got it?
Got it.
Another more advanced and more sort of like an older version of dealing with these applications is through what we call a command line interface, or CLI. If you want to find sort of like a acronym for it, like GUI, this is called a CLI, command line interface applications. Like for example, Git is one of these applications. I can run it here and it would output some sort of a help information for me that, hey, this is how I'm supposed to be used. It doesn't have a graphical user interface, right? The way I interact with it is by providing options to it. Git version, it prints its version. Git clone a repo. Git clone a repo and a path of repo. These are arguments that I pass to it. The first argument, the second argument. They go into this application and it reads them. Based on the arguments, it decides what to do and sort of like does that job for me, right? Two completely different types of applications. Got it?
Got it.
Python is a programming language, is an application that sort of like expects this kind of interaction. Python 3 is just like a Git, just like VLC, just like Revit. It's a piece of executable that runs on your machine, right? The way we interact with Python is that if you don't provide any arguments to it, it'll go into interpreter mode. If we do provide arguments to it, like a path of a script, it runs that script for us. And it's got other arguments too. There's a whole bunch of them. I got to them by putting -- help in here. Or tick help, right? Python 3, let's see the version. Does that make sense?
Mm-hmm.
What I'm doing here is just like clicking on, like, I don't know, like VLC, going into the menus and getting the my God damn it, this is okay, VLC about. See the version. right? It's the method of interaction is the one that's different. Cool?
Cool.
Okay. Software stack. Oh, talking about this, I added these images at the end of this. So this is the tape of our application. This is the tape of our operating system. There are two different programs running on our machine. This is our terminal at the bottom, or shell, we could call it. Well, I don't want to get into like sort of like defining these, defining the exact meaning of these terminologies. You can use shell or terminal interchangeably. This is your app, like Python 3 or like Git. These are the series of arguments that we pass to it. When we write this in front of the application and hit enter, the operating system takes those, provides them to the entry point of our app. The app looks at those, processes the logic, and does what it needs to do. Got it? So now you can see, depending on the options that I'm providing to the app, the application might have different endings. Got it?
Mm-hmm.
Okay. And then let's look at the GUI applications. GUI application tape has a series of functions like make window, yes, delete, or no cancel, like 3 different options. The application make window, the logic, asks the operating system to give it a window. That's why all your application windows are kind of look like the same, because they all are provided by the window manager, right? Most Windows applications, the windows, they exactly the same. They close and the minimize and all that stuff are in the same spot, and the title and the icon and all that kind of stuff, because they come from the operating system. In this case, we launch an app, the window that says, do you want to delete all the walls? No, yes. When you click on yes, it sort of like calls into a function that's inside our application that does the deletion of the walls, and no is that it does the cancellation. Got it? Mm-hmm. So the tape, the application tape is still the same. We define different functions and different pieces of logic to it. We just, depending on if we are creating a command line application or a graphical user interface application, the interaction with our application is slightly different. Cool?
Cool.
Okay. So I want to address your question of this terminal here or like this terminal here. Let's actually look at RPS and not confuse ourselves again. This is a window for the RPS. That big window is the window that Revit Python shell asked the operating system to give to it, right? Inside of this window, it created 2 different panels, one at the top and one at the bottom. Don't worry about the toolbars and stuff like that in the middle. Let's just talk about these 2 panels. This is a text box panel. It accepts Python code. Behind the scene, in its memory, there's an item Python engine is running that executes whatever we write here or here. Got it? Mm-hmm. So on top of this window, it'll launch an instance of IronPython in interactive mode. So I can say b equals 12, and it works, right? Just like the part that we saw here, just like this. Right? On the bottom part, it provides a text box and lets us write Python. But when you hit run, it actually runs it with the same engine. So when I say run, see, I get 1 new prompt here. It means that it just executed discretely what I had sort of like placed inside this Python box. So if I say A here, now there's a value for A too. A was defined here. Does that make sense?
Yep.
Okay. So don't sort of like you're going to see a lot of this stuff like how Python is running inside another application. Like you would see that inside Visual Studio also, like terminal, new terminal, and you see the shell is running here, and we say like Python, and Python is running here too. Just know that applications are a lot more flexible than what we're used to. We're used to seeing Revit as one application, right? But applications can run inside of each other. They have to sort of like, the programmer have to adopt a mechanism for that to happen. But like this is Python running inside of Visual Studio Code. Rhino inside Revit does the same thing. It runs Rhino inside of Revit. They're in the same kind of tape or memory space. Sometimes not, depending on the architecture. So there's a nesting between these applications. This is IronPython running inside Revit Python shell running inside Revit. Got it? But because they're all sitting in the same memory, they all have access to each other. You can't do this with every application, but a lot of application actually provides this this mechanism. So just take this much out of it, out of what I said. Ask me questions. I think you have questions. There's a part of this that doesn't make sense.
I get it.
Okay, last part. Well, last part before we get to history. You asked me about what is a PowerShell or what is command line, like CMD in Windows, or PowerShell in Windows, or Windows Terminal in Windows. Actually, I have that one open. Windows Terminal in Windows. Like the 3 different shells that we have in Windows, right? These are CMD or PowerShell or Windows Terminal. They're just another program, just like Revit or Python or Rhino or just like that, right? They're a different program. What their job is to give you a command line interface so you can run applications that are CLI, right? It's like a big window for all these CLI applications. It's like your Windows has the desktop environment for all the GUI applications and has the terminal. Here I'm using the right term, the terminal, which is this window for everything that's CLI. Got it? Does that make sense? So Git is like, this is my terminal, and in macOS is literally called terminal, and in Windows, I would highly suggest forgetting about the command prompt and PowerShell. These are kind of old. The window, the sort of like PowerShell itself, and use the new Windows terminal. It also sort of like has a better architecture and it has a better name for it and all that kind of stuff. Inside this terminal, you can launch, just like in a GUI environment, I launch VLC. Inside of this environment, I can launch Python 3, right? Or I can launch Edgetop. See, it could get graphical a little, right? Or I can launch MC. Remember these from the old times? They're CLI applications, but they use this text-based environment as their graphical user interface. There's actually a subset of them called CUI, which is command line user interfaces, just like this one. Got it?
Got it.
Does that make any sense?
Yep.
And you can launch multiple different instances of this terminal. You don't have to have one only. You can launch as many of them, and sometimes they support tabs too, so you can have multiple different terminals running, just like here too. I can have 2 different PowerShells running inside this terminal. Okay, and as we go further, as we get more advanced, I'll actually tell you what a shell is. Right now, feel free to use terminal and shell interchangeably. It doesn't matter. We'll get to it in later detail later on. Okay, so as a sort of like a more of an advanced user of graphical operating systems like macOS and Windows, be familiar with the desktop environment, the graphical user applications, the GUIs, and with your terminal. Always go into your operating system. If let's say you launched Ubuntu Linux tomorrow, it has a graphical user interface. Look through the applications, find the terminal. Terminal is the one that gives you sort of like access to all the GUI, all the CLI applications that are available on that machine, right? I'm not going to get into too much detail about this, but some applications have both interfaces. They have GUI and they have CLI, depending on what options that you're providing to them. We'll get to those stuff later. It really doesn't matter at this point. So basically just to end this session, I want to introduce these two people to you, Ken Thompson and Dennis Ritchie. They're the 2 people shown in this photo here. They're the one, Ken Thompson is the one that designed the Unix operating system that, other than Windows, any operating system in the world that we use is loosely based on Unix. Linux, macOS has a Unix-based kernel, FreeBSD, OpenBSD. FreeBSD is the operating system that runs Netflix. macOS is the operating system that sits on top of sort of like all the Mac machines. iOS, iPad OS, all these operating systems are Unix-based operating systems. The architecture that he defined was so good and was so timeless that it's still used today. This sort of like program that I use here called LS that lists stuff, or the program that's called, let's say, I don't know, let's say LS, I don't know, a lot of applications. Like you got a sort in here, you got unique that finds a list of unique names in a list and all that kind of stuff. All these applications actually are created by this person and sort of like created as part of the original Unix operating system. He's also credited by doing two other things for us. Number one is grep that we use a lot, or regular expressions that we use later on in our programming a lot to be able to search for text patterns inside a text. And he's also the person who designed the UTF-8 file system, text encoding that pretty much all the web is based on right now. It was such a genius design that he did that sort of like shortened the length of the data, and it also was fully backward compatible with all the ASCII systems that we had. So just know his name. He's also one of the designers of, one of the architects of the Go programming language. Also, he works at Google right now. Dennis Ritchie died at the same week that Steve Jobs died. He's the person that designed the C programming language. They worked alongside together. C was the programming language for the Unix operating systems. Anything that we touch today has some sort of a module that's written in C, running on sort of like a Unix-based operating systems. These two people are huge in the sort of like they have a massive role in the growth of the computer science and the sort of like the technology stack that we are sitting on. Any questions?
No. The history is really nice to know.
Yeah. There's a question. So terminal automatically reads all the directories on our machine to find the app you're asking to launch it. Yeah, basically, yeah. Terminals have a way of, like, you have a way of setting search paths for your terminal that says, hey, like these are the places on my machine that I've put programs in. So when you say git, it'll go there and find sort of like all that kind of stuff. It's not better than to learn C than Python, because C is far more complex, and we'll get to discuss this later. C is actually a compiled programming language. So it's not as forgiving and nice to use as Python. You can just create a Python variable and throw any value in it, and Python won't complain. It'll actually work around with you. C is very strict. C is like the most strict language that I know before getting into like assembly language.
Well, I guess it's also like based off like what you want to do with
Exactly.
the code,
that's the right answer,
right?
Yeah.
For
the right answer.
For Revit, Python makes a lot of sense.
Python and C# make the most sense for the Revit environment. How much time do we have?
2 minutes.
Okay, so let's close it. There are a couple of items here that are turned into check marks. We'll talk about these in the next session as sort of like part of the recap and stuff. We might have a longer recap next session. This is a bigger topic. I thought we are gonna move through this stuff quickly, like faster this time based on our performance on the last session, but it's okay. I think we might have to add another session or something. I don't know. We'll figure this out.
All right. Well, on that, huge thank you, Ehsan, for all this. I think there's a lot of instruction and training in that. Dana, thank you for participating in this and just learning publicly. I think takes a lot of courage to do that. And then thank you to everyone who's watching this. I hope that it's been helpful for you. Definitely give kudos to these two in the Slack channel. We definitely want to help you out if you're running into problems. And also, we don't have to be the ones that help people out. If you have a problem, put it on the Slack channel. Somebody else might help you out. And we definitely want it to be kind of a learning and growing community. So before we close out, any final comments?
No, make sure you like this channel and look out for all the other Your Desk University sessions, because there's some really wonderful information, not only from Ehsan, but from all of the industry experts that have presented.
Yeah, that sounds good. And I am going to leave this running for just a moment, but I'm going to mute us. So bye, everyone. See you guys later.